Okay, so let's look at practice test 1, number 1a. So we're given this differential equation. We have to solve for dy dx equals negative 2x y squared plus 1 over x times x squared plus x squared y plus ln of x. So we have to find the slope field over the rectangular grid. The grid is m over 2 in the x position, n over 2 in the y position. M gets to go between 1 and 3. So m could be 1, 2, or 3. And n could be negative 1, 0, 1, or 2. Okay, so we have to find the slope at each point in our grid. Okay, so let's make some observations. So first note, if m is 1, because m could be 1, 2, or 3, so suppose m is 1, then m over 2 would be 1/2, then that's our x value. So then x would be 1/2. Let's plug this now into our differential equation up here. So in place of x, I'm going to put 1/2 up here. So doing that, we get then. So plugging 1/2 in place of x up here, everywhere, we get this then. And that's going to be a fourth there. That'll be a 4 times y. And we've got a half in front here. I'm going to multiply top and bottom by 8 here to simplify it a bit. So I'm going to multiply top and bottom by 8. I replace the 1/2 squared as a fourth here and here. So multiplying the 8 in here, well actually the 2 and 1/2, that just becomes y squared there. So just y squared there. Then multiplying this 8 in, we'll get then the following. So multiplying by 8 then, we'll have negative 8 on top, then 8 down here. The 1/4 and a half becomes an 8, so that would cancel. That would cancel there too, and 8 divided by 2 be 4, so it'd be 4 in front of the ln, so we have this. Then in your calculator, if you do 4 ln 1/2, and you add it to 1, you should get then. So combining the 1 and 4 ln 1/2, I just run it to one decimal place, is negative 1.8, so we could write this then as this for dy dx. That's when x is 1/2. Alright, let's keep going. So next, when now m is 2, because again m can be 1, 2, or 3, so we're going through the different m values. So when m is 2, we put 2 in place of m here, it'll be 2 over 2, so your x would be 1 in that case. So let's find my dy dx, so using this guy up here with x being 1 now to find our slope. Doing that, we get, so putting 1 in place of x up here for all the x's, we get this then. And the ln of 1 is 0, so it's got a 0. So simplifying this, we get then, we get in dy dx equals negative 2 times 2y squared plus 1 over y plus 1. Okay, so let's summarize what we have so far. We still need to stick in m being 3, but I'm out of space, so let me just summarize, and we'll go from there. So summarizing, we have this then. So we still have to do m is 3, so let's do that next. So when m is 3, that's the last value m can be up here, then x would be 3/2. So let's put 3/2 now in place of x up here for my dy dx guy. So doing that, we get then. So we get this then, so plugging x in, 3/2, working it out, we get this. Let's multiply now top and bottom by 8 to make it look a bit nicer. So doing that, we get. So multiplying top and bottom by 8. Here, these two cross off, just becomes minus 8, 3y squared plus 1. Here, the 4 and 2 cross off with the 8 here, it'll be 9, 3 times 9, 27. 27, oh, it should be y in this one. 27y here. And then 2 and 8 equals 4, it'd be 4 times 3 is 12, so it'd be 12 ln of 3/2. And let's work out, on your calculator, work out 12 ln of 3/2 plus 27. So adding those together then, we get, so combining the 12 ln of 3/2 plus a 27, rounding to one decimal place, it's 31.9 roughly. So this is our dy dx. This is when x is 3/2. Okay, so next thing. So next note, so the n value up here can be -1, 0, 1, or 2. So you have 1, 2, 3, 4 values. But the y value is going to be n over 2. So the y values then could be -1/2, that's when n is -1. 0, that's when n is 0. 1/2, that's when n is 1. Or 1, that's when n is 2. Okay, so let's summarize everything we have so far then. I'm going to erase some things here now and let's summarize. Okay, so summarizing, this is what we have. When x is a half, we find our y prime was this. When x is 1, we find our y prime was this. When x is 3 halves, we find our y prime was this. And we mentioned that y could be -1/2, 0, 1/2, or 1. So you have to go through and find y prime at each of these values then. So you be 1/2, -1/2, say. So let's do that one first. So let's look at y prime of 1/2, comma -1/2. So pretty much you're putting -1/2 in place of y in this guy over here. And when you're doing that, you get this. And working that out, you should get then roughly 4.35. Okay, let's do now. So let's do all the ones when x is a half. The next will be 1/2, 0. So that one next. So now putting 0 in place of y here and here, so we're looking at y prime of 1/2, comma 0. So you can check it's roughly equal to 4.4. Okay, so let me do the 1/2 and 1 next. So you check then y prime of 1/2, 1/2. So putting 1/2 in place of y up here, working it out, it's roughly 7.7. And then y prime of 1/2, 1, so putting 1 in place of y up here, working it out is 20. Okay, so we've done this first one now with all the y values. Let's do this one next. Okay. So next we'll do y prime of 1, -1/2. So be using this guy now, putting y being -1/2 in place of y here and here. So that's what I've done here. Working that out, you get -3. Okay, next, let's find. So y prime of 1, 0. So again, using the second one with y being 0, working it out, you get -1. Okay, let me do the last two also here. Last two on this one. So doing that, we get. So let you check that y prime of 1, comma half. So using this guy with y being a half, that's also -1, same as that one. And y 1, 1, so using this with y being 1, you get -3 halves. Okay, so let's now move on to this one. So now moving on to y prime of 3 halves, -1/2, so I'll be using this guy here now, with y being -1/2 here. So doing that, I put it in there, so it'll be -1/2 squared here, here. So working this out, I'll let you check, it equals -0.76. And now let me give you the last three guys now. Let me write them down here. So that you check that y prime of 3 halves 0 is -0.25. Y prime of 3 halves, comma 1/2 is -0.31. And y prime of 3 halves, comma 1 is -5.4. Okay, so let's summarize what we have now. So summarizing, here's all the guys we found. Now we need to plot these. So these are the slopes of the tangent lines. So we need to plot them now. So let's do that. Okay, so I made my grid here because these are all the grid points. So you'd have 1/2, -1/2, 1/2, -1/2 would be here. Then you'd have 1/2, 0, which would be here, and so forth. If you grabbed all these points to be these here, Now we're going to have to do the slope at each of the points then. So the first one has slope 4.35. So recall that, so for example, that would be slope 1 there roughly, and straight up would be infinite slope. So slope 4 would be steeper than this guy here, so it'd be maybe like that or something like that. So let me graph it in. I'll put it down here then, so the slope here should be roughly 4.35, which is approximating, so it doesn't have to be perfect. And the slope at 1/2 0, which would be here, is 4.4, so it's almost the same as this one. Let me graph that. So I've done it here, and at 1/2 1/2, the slope is 7.7, so it's getting steeper. And at 1/2 1, it's 20, so it's even steeper. So you put these two in now. Okay, so we've got those two. Now let's go on to this line. That's when the x is 1, so we're going to be going along this guy here. So it's 1 comma negative 1/2. It's slope -3. So negative slope would be going this way. So -3. Let me put it in. So something like that here. And then at 1 0. So right here it's at -1. Let me put that in. Up here, and at 1 1/2 it's also -1, and let me do this one also. At 1 1 it's -3/2. Let me do it. Okay, so I've got those. Now we're going to go along this one. This is this last 4 dots here. This is negative 0.76 down here. Let me do that. Something like that, and negative 0.25. Let me do that one. So something like that, and then negative 0.31 and negative 0.54. We put those in. So there we go. Now let me just write the original dy dx here for a second. So here's the original dy dx over here. So note if you put 0 in place of x, you'd be dividing by 0 down here, so it'd be undefined the slope. So it'd mean actually at these points, you have vertical guys here, 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 and here. We're going to need that for the next part of the question. Okay, now let's do part B of the question. So part B says, use slope field, so this guy would be here, to sketch an approximate solution curve passing through y of 1 equals 0. So y of 1 equals 0, that means 1, 0. So right here, so it needs to pass through this guy. So sketching the curve in then, so it's going to go along this. And I'll draw it in here and I'll explain how I got it. Okay, so it looks something like this. It's kind of tricky to draw it in here because the tangent lines here got positive slope and negative slope here. But it looks like as you're going out this way, the tangent lines are becoming flatter. It's going to come along here and here. And up here it looks like it's going to maybe shoot up this way. Yeah, it's kind of tricky to graph it in from the tangent lines we have here, but that's the approximate solution curve anyway. In question 2, we'll look more at this question actually. Okay, so we're done with question A and B now. So let's leave it there.